Hey everybody, welcome to Eureka Math / Engage New York Math, Module 5, Lesson 8, Drawing Polygons in the Coordinate Plane. I'm Mr. Quick, and we're going to be talking about when you're given coordinates, can you draw a polygon on the coordinate plane, and then can you find the area of that polygon? Now, some of those are going to be much easier to do than others, as we'll demonstrate here in just a moment, and some are going to be a little bit more complicated where we're going to have to compose or decompose other shapes around the polygon, as we've done before, but this time it'll be on the coordinate plane. So let's go ahead and get started. We've got a portion of a coordinate plane here, and I'm going to give you some coordinates. Okay, so we're going to graph these coordinates, and then we're going to name the polygon. So A is 3, 2, so we're going over 3, up 2, and if I can mark it, there we go. B is over 3, up 7. So over 3, up 7. Not quite. It's got to be perfect, right? There we go. And then C is, which I'll label these off to the side here. C is over 8, up 2. Close. Okay, and so now we're going to connect these dots, right? Connect the dots. One thing for sure, it's going to be hard to do on the iPad, so it might look a little funky, but when you're doing it on paper, make sure you use a ruler or something to make your lines straight. Okay, connecting all the dots, we can see that we have a triangle, right? That's a pretty easy one. And as you can see there, it's a right triangle. So we want to find the area. We know that area of the triangle is 1/2 base times height. So our base starts at 3 and goes to 8. So that's going to be 1/2 times 5 times, and then our height starts at 2 and ends at 7. And so that's also 5. Erase some of this, make some room. 5 times 5 is 25. Times 1/2. 1/2 times 25. Our area equals 12.5 units squared. We do have to say units squared. We say units because it doesn't specify, like, are these supposed to be inches, feet, miles? We don't know, right? But what we do know is that this is 12.5 units squared. Now, I'm going to give you 3 different coordinates, and we're going to see if we can graph those and notice what the difference is. Okay, already we know it's going to be these different, this different shape is going to be, one, likely it's going to be a triangle, right? Because there's 3 endpoints, but we can see that the x-coordinate is they're all negative, and so we're going to be in a different quadrant. So let's start at E here. -8, 8. So we're going to go back to -8. We're going to go from -8 up to +8. We're going to mark that. All right. And we will label that E. F is at -2, so back 2. And then +5, so we're going up 5. Mark that there. And then G is -7, up 2. So we'll mark that there. Now, let's label. Don't forget that, like I just did. Let's connect the dots. Okay, not the best artwork, but you get the idea. We do have a triangle. And what's different? Well, the big key difference here is this one was really easy to find the the area for, because we had the height, we had the base, and it was very simple. This one, the lines don't go straight across the x or y axis. They go diagonal. So what can we do? Well, I'm going to show you a little trick here. I don't know how far this goes across or this goes down this way. It's hard to tell because, again, it crosses through the middle of some of these shapes. But what we can do is build a new shape around it, something like this. Okay, so I've put a square around our triangle. And the reason I did that was I started basically in this corner, which is I know is my height, and I went down to the lowest point, okay, and then went over to -2 because I know there was a point on that line, and basically just connected all those dots. So, as we know, and this is going to take us a few steps here, the area of a square is side squared. So we can take any of these sides and count them up. So we go from basically 2 to 8 here. So I know that the side is 6 squared, right? So the area of the square, put the square here so I remember, the area is going to be 6 squared, so 6 times 6, so 36 units squared. That's the whole square. I don't want the square. What I want and what I need to find out is the triangle within the square, so which would be inside the black triangle. Now, what I can do though is I can find out the area of these triangles that are on the outside, and then once I have all three of those areas, I can subtract them from the 36 units squared, and what is left will be the portion that's inside the black triangle. So let's take a look at that. Okay, we'll call this little triangle here 1. So the base obviously goes from -8 to -7. So remember, we have 1/2 base times height. For triangle 1, we're going to say that's 1/2. And again, from -7 to -8 is 1, so that's my base. The height is going to be the same, right? It goes from 2 to 8, so it's going to be 6. So 6 times 1 is 6, times 1/2 is going to be 3 units squared. Triangle 2, we'll go ahead and do in green, will be this portion up here, and I know that my right angle is there, so we're going to have, we'll say triangle 2. We go from -8 to -2, so once again, it's going to be 1/2 times 6, because there's 6 in between there. If we count it over, 1, 2, 3, 4, 5, 6, times the height, which goes from 5 to 8, so that's going to be 3. We have 6 times 3 is 18, times 1/2 is going to give us 9 units squared. And then finally we'll do triangle 3, which is over here, and we're going to have 1/2, that's triangle 3, 1/2, the base, we're going to go from -7 to -2, so that's 5. We go from 2 to 5, which is 3. 5 times 3 is 15, times 1/2 is 7.5. So now we're going to start with our 36 units, and we're going to subtract each of these, because we made it into a square so we could find the area of the entire square. Now we're going to take away each of these individual triangles, and what's left will be what is inside the original triangle we wanted to find. So we're going to take away 3, which is this one. Next we're going to take away 9. And then next we're going to take away 7.5. So 36 minus 3 is 33. Minus 9 is going to be 24. And then minus 7.5, we're going to end up with 16.5 units squared. So, again, that was pretty complicated. There's a lot to it, but it's just a matter of whatever shape you have, you can break it down into smaller shapes that you know how to already find the area of, and then subtract, right? Or in some cases, you may have to add the pieces together. So we'll stop right there. We'll do some more examples in class. Thank you for watching. We'll talk to you soon.